In this question, we are going to calculate output voltage of the given circuit. The circuit is comprised of op-amp and diode connected transistors of 32 numbers. And given that op-amp is ideal as well as all the transistors, total 32 transistors are identical in all respects. And they have infinitely large values of common emitter current gain such that that means you can neglect the base currents. And collector current equation with respect to base emitter voltage is given by this expression. IC is equal to IS into e power VBE by VT. That is a relation between collector current and base to emitter voltage of each transistor. Given that VP, voltage across this point, VP is 0.7 volts and thermal voltage is 26 millivolts. We are going to find V out. How much is the V out voltage? Okay, so look at the circuit. It's going to be looks like a typical circuit, but it is very easy to calculate. Okay, so first it has given op-amp is ideal op-amp characteristics. Okay, voltage gain, open loop voltage gain is infinity. From this open loop voltage gain is infinity, you can write it as, okay, we can say V plus is equal to V minus. When open loop gain is infinity, there is a virtual short exists. Virtual short means even though the two terminals, non-inverting and inverting terminals, are physically separated, but they will be at the same voltage. They will be shorted. Okay, so V plus is equal to V minus. That is the first important point. And second important point means ideal op-amp will have RI, input impedance of infinity. That means current flowing through non-inverting terminal and current flowing through inverting terminal is 0 amperes. So no current is drawn by the input terminals. Current flowing through inverting and non-inverting terminals are 0. And voltage across inverting and non-inverting terminals are same. These are the two important characteristics you should remember for the ideal op-amp. Okay. So now, with respect to non-inverting terminal, we can write with respect to non-inverting terminal means with respect to this terminal. Okay, look at this one. Current flowing through this 20K is same as the current flowing through this Q1 transistor. Okay, because no current is drawn by the non-inverting terminal, the current which is flowing through 20K, that should also flow through this Q1. Okay, so you can write it as current flowing through 20K is equal to current flowing through Q1. That means current flowing through collector current of Q1 transistor, IC1. Okay, so this can be written as current flowing through 20K. You can calculate if you know the terminal voltage at both sides of 20K. Okay, because you know the resistance value. If you know the voltage across 20K, then you can write the current equation. Current is equal to V by R. So this you can write it as V out minus, okay, V plus. V plus means voltage across non-inverting terminal. Voltage across non-inverting terminal divided by 20K is equal to IC1. Current flowing through Q1 transistor is IC1. Relation between IC1 and VBE1 can be written like this: IS times of e power VBE1 divided by VT. Okay, and this V plus, you can write it as V plus is equal to V minus because of virtual short, and V plus is nothing but VBE. If you are going to write the terminals, this is collector and it is base, this is emitter. So voltage across base to emitter is BE, and since it is Q1 transistor, I am introducing a suffix 1. So this one VBE1, which is same as the voltage across non-inverting terminal. So V plus is equal to V minus, which is equal to VBE1. Okay, write it now. V out minus VBE1 divided by 20K is equal to Is times of e power VBE1 divided by Vt. This is equation 1. This is equation 1. Next, with respect to non-inverting terminal, with respect to inverting terminal. With respect to inverting terminal is this one. Current flowing through this 20K, current flowing through this 5K is same as the current is dividing into 31 transistors. Q1 is on the non-inverting side, the remaining 31 transistors are connected at inverting terminal and all are identical. If you say the current flowing through each transistor is I, okay, each transistor is I, and you can write it as 31 times of I, and since it is collector current you can write it as IC, so this is 31 times of IC. Current flowing through 20K is same as current flowing through 5K is equal to 31 times of collector current. So we can write that equation. I20K is equal to I5K is equal to 31 times of IC. Okay, and I20K can be written as, that is current flowing through this one, current flowing through this 20K resistor can be written, okay, as V out minus V minus divided by 20K is equal to, okay, current flowing through 5K, current flowing through 5K can be written as V minus minus Vp divided by V minus minus Vp divided by 5K, that is equal to 31 times of IC. Okay, so now V minus can be written as, V minus is equal to VBE1, so you can write it as V out minus VBE1 by 20K is equal to, okay, VBE1 minus Vp divided by 5K is equal to 31 times of IC. Say this is equation 2, and we are going with only two terms of this one, this and this one, so you can write it as V out minus VBE1 divided by 20K is equal to 31 times of IC can be written as Is into e power VBE by Vt, that is general relation, and here VBE for all the transistors is same, which is equal to Vp. So we can write that equation as Is into e power Vp divided by Vt. Okay, say this is third equation. Divide 3 by 1. Divide equation 3 by 1. So V out minus VB by 1, VB1 by 20K is same. So divide 3 divided 1, you are going to get it as 1 is equal to, okay, 1 is equal to 31 times of Is get cancels, e power Vp by Vt divided by e power VBE1 by Vt. So you can write it as 31 times of e power Vp minus VBE1 divided by Vt. Okay, so from this one, 1 by 31 is equal to e power Vp means 0.7 minus VBE1 divided by Vt. So 0.7 minus VBE1 is equal to, okay, Vt natural logarithm of 1 by 31. 1 by 31. So from this VBE1 can be calculated as, VBE1 is 0.789 volts. VBE1 is calculated as 0.789 volts. Once you have calculated VBE1, you can calculate V out. Okay, from equation 2, okay, now you concentrate only on these two. Okay, from equation 2, V out minus VB1 is calculated as 0.789 divided by 20k is equal to 0.789 minus VP. VP is 0.7 divided by 5k, and it will become 4. So V out minus 0.789 is equal to 4 times of 0.089, which is around 36, which is 356, and V out is equal to 0.789 plus 0.356, so it is approximately equal to 1.14, okay, 1.45 volts. So the right answer for this question is, okay, V out is equal to 1.145 volts. This is the right answer. Thank you.